Hello everyone, Samir here, and today we will look at a JEE 2024 problem of 3D and vectors. Okay, so let's read this problem. It says that let R cube denote a three-dimensional space. It will be R by R by R. So it denotes a three-dimensional space. Take 2 points P and Q. Okay, and this notation dist xy denotes the distance between points x and y in 3D space. Okay, now it defines a set in 3D space. X belongs in R cube such that distance between x and p square minus distance between x and q square is 50. Similarly, it defines a set T, okay, where y in R cube is distance between yq square minus distance between yp square equal to 50. And it's a multi-correct problem. Okay, so it gives us option. There is a triangle whose area is 1 and all vertices are from set S. Okay, there are two distinct points L and M in set T such that each point on the line segment LM is also in T. Okay, then it says there are infinitely many rectangles of perimeter 48, two of whose vertices are on set S and two are on T. Okay, and there's a square of perimeter 48, two of whose vertices are on S and other two are on T. Okay, so these kind of problems look intimidating. Okay, they give a sort of intimidating look, but these are one of the easiest problems that you will find in JEE mains. Okay, so there is roughly, if you are able to find what is set S and what is set T, there is nothing much left to do in this problem. Okay, so one of the approaches you can find is you can take the coordinates of x as xyz. It is a variable point. P and Q are given. Okay, and then apply distance formula in 3D and find its equation in Cartesian form. Okay, but vector form gives a even shorter path to this. So we will just see. Okay, so we are not going for coordinates as it's little longer. Okay, and you don't need to get intimidated seeing this problem. Okay, now this distance xp square, it's basically the distance between the vector joining points x and p. Okay, so it becomes mod x minus p square. Okay, similarly, distance between x and q is mod of x minus q square. Okay, I'll just show it. If suppose this is point x and this is point P, so distance between x and P is, you join xp. Okay, so it is the mod of this vector xp. Okay, so x minus p square minus x minus q square. Now this part, okay, mod of x minus p square, you can write as x minus p dot x minus p. Okay, x minus p is a vector, this one. Okay, similarly, x minus q square becomes x minus q dot x minus q. Okay, so we just open these brackets. It gives x dot x minus 2 times x dot p plus p dot p minus x dot x from here plus 2x dot q minus q dot q. Okay, so we come x dot x gets cancelled out. We combine these two. Okay, so 2x we take common, you get q minus p plus mod p square minus mod q square. P dot p we wrote as mod p square and q dot q as mod q square equal to 50. Okay, which is given to us. Okay, so now we put the values of mod p square and mod q square, which you can easily get from here. Okay, so mod p square will be 3 square plus 2 square plus 1 square, and mod q square is 4 square plus 2 square plus 7 square. Okay, so we get, we take these on other sides and you get the equation of set S as 2x dot q minus p equal to 105. Okay, so now this is the equation of a plane of the form r dot n equals to d. Okay, this is giving you, this x is your r. Okay, this q minus p will become vector n. Okay, and this is your d. So this is a plane. Set S is representing a plane which is perpendicular to Q minus P. Okay, so it is perpendicular to the line joining Q and P. Okay, suppose this is point P and this is point Q. Okay, so plane will be perpendicular to the line joining these, something like this. Okay, so plane is perpendicular to this line. Okay, now the process that we applied for set S, the same process we apply for T. Okay, so in this for T, it is just the point, the distance is from Q minus distance from P and square of these. Okay, so this you will get, you just replace X with Y, Q minus P will be replaced with P minus Q, and mod P square minus mod Q square with mod Q square minus mod P square equal to 50. We again put the values of mod Q square, mod P square, and we get T also as a plane. Okay, here Y is R dot N. Now, for set S as well as set T, you can see that both are planes, both are perpendicular to the line joining QP. So both these planes are parallel planes. Okay. So both S and T are parallel. Okay. Now, if you have two parallel planes of the form R dot N equal to D1 and R dot N equal to D2, the distance between them is mod D2 minus D1 upon mod of N. Okay. So in our case, we just apply this formula. So D1 minus D2 will be 105 minus 5. Okay. Upon we take this to mod P minus Q here. Okay. So this will be 100 by 2 will give you 50 upon mod P minus Q. Okay. So mod P minus Q you can find from here, because it is given, it will be 4 minus 1, 3 square plus 0 square plus 4 square, 7 minus 3 whole square. So mod P minus Q comes out to be 5. Okay. So the distance between these two parallel planes is 10. Okay. So we see these are 2 points P and Q given. Okay. And these are planes set S and T which are parallel to each other. Okay. So since this S is a plane, okay, you can draw any triangle of any area inside that. Okay. So this was our first option, whether you can draw a triangle of area 1 in set S. So you can draw a triangle of any area on set S, since it's all the vertices lie on the same plane. Okay. Now on set Y, if you join points L and M, okay, so all the points are going to between L and M will lie on the plane. Okay. Now the distance between two planes is 10. Okay, as was shown to us. And the third option was that there are infinite, whether infinite rectangles of perimeter 48 are possible or not. Okay. So the if you take, just directly opposite points, this distance would be 10, this would be 10. So 20, and this distance you can take as, 14 and 14. So you get rectangle of 48. Okay, and then you can change this distance, you can shift these points and get as many rectangles as possible. Okay, you can draw here, you can draw at another place. Okay, so infinitely many such rectangles are possible. Now for square, we'll see, since distance between these two is 10, we'll have to offset these 2 points a bit. Okay, so we are seeing here the points we have taken on T, they are not just opposite to points on set S. We'll just offset those points a bit, so the length of this line and this line becomes 12. Okay, for the perimeter to be 48. So we have just offset this one a bit. Now we see the same thing in the diagram. This is set S, this is set T, two parallel planes. Okay, you can draw a triangle in set S here. You can draw a line in set T because it is a plane, and all the points between L and M will lie on this plane. Okay. Now for rectangle, okay, you can either take vertically opposite points or offset points and draw as many rectangles as possible. Okay, with perimeter 48. For square, each side has to be 12. So you draw length 12 here, okay. And you have to take the other 2 points on the other plane little bit below so that this length also becomes 12, okay. You could have taken it little bit up also, okay. So there are many squares also possible with perimeter 48. That is why the distance between two planes, which was 10, was very important. Okay, if this distance would have been greater than 12, then no square would have been possible. Okay, now you see the problem initially, which looked so intimidating, is actually pretty easy once you see the hidden structure given in the problem and how simple it is. Okay, so for more such problems and insightful and new kind of solutions with new ideas, keep watching further videos. See you in the next video.